So this is the Raspberry Pi cluster. It's a Beowulf cluster built out of 33 Raspberry Pis. I started working on this a couple months ago in response to a need I had for my dissertation work, in which I was developing a distributed simulator which needed a cluster environment to actually operate. So this seemed to be about the cheapest way you could build a 32 node or 33 node cluster. So kind of some of the novel things about this build are, I think, the rack design and the power management system. So if I take a look here at one of these stacks, you can see I have used PCB standoffs to build each of these columns to allow each of the Pis to stack one on top of each other. And that allowed plenty of room for component clearance and for air to get through to keep things cool. And then on the top and bottom, I have drilled plexiglass in that same pattern to hold the whole structure together. Now for the power management, you'll notice, so normally you would use USB, this little micro USB connector on the corner, to power a Raspberry Pi. And you can see I'm not actually using that in the system. Instead, I built a custom PCB, just sit here, that distributes 5 volts to each of these stacks, as well as you can see, providing a tricolor LED. And there's these wire jumpers that go between each PCB to allow power to be moved between the top and bottom of the stack. So I just bring power into one place on the stack, and the whole thing is powered. And so my regulated 5 volts I'm actually getting from a couple PC power supplies, because they provide up to 30 amps at 5 volts, so you got plenty of power that's clean and plenty clean for running on Raspberry Pis. So one other thing with the PCB board here is that whenever you power through the 5 volt pin on the GPIO header, you are actually bypassing a fuse that's normally that is present between the USB connector and the 5 volt rail. And so I went ahead and added that back in to this PCB as well, so that I still maintain short circuit protection on all the boards. So we pull around the back here. I've got some air cooling, which is certainly overkill for the amount of heat generated by Raspberry Pis, but I am overclocking all of these to 1 gigahertz, so they do get a little bit warmer than they normally would, but even so, they don't ever get to temperatures that really require the fan cooling. But it looks cool, and it does keep them a lot cooler than they normally would be as well. So on the corner here, this is one of the PC power supplies that I'm just using the 5 volt rail off of that. We got another one on the other side. Then we got 48 port switch that all these cables, Ethernet cables, are running into, and then just a couple power cables coming from each of these PC power supplies to power each stack. So the program that I have running on here is just a parallel program using MPI, and effectively this node on top, master node, is directly controlling the LEDs on all the rest of the nodes in the cluster. This is just kind of done to showcase the whole thing operating as a cluster and show how tight a synchronization is actually possible with communications using parallel programming. And in any case where you have a single LED that's being lit on a node, it's just doing a regular MPI send receive operation. However, on cases where you have multiple LEDs on distinct nodes lighting synchronously, those are actually in response to broadcast messages. You can see you get very tight timing between the different nodes. They were truly operating as one program, one machine. So we'll let it sit here and run through some of the different patterns. You got a spiral, blink all, different colors. So the software I have running on here is Arch Linux. I chose that because it's far more lightweight than Raspbian, lots smaller process list once you booted the system, because you don't have a graphical environment installed by default. And then really, aside from that, it's just a matter of having an NFS share set up so that you have a common file system between all the nodes and some kind of MPI package installed. There's kind of the rainbow look with the strobing. So at this point, I've been able to move all of my simulation over to this platform, and it's performing really well. And it's been a really fun project to work on. It's pretty cool to have a 32 node cluster that can sit on your desk, just about.